Hi, I'm Daniel Rose and I'm going to explain today how the immune system works. Hi, I'm Daniel Rose and I'm explaining today how the immune system works. There's three things that I want you to take away from this video today. The first is, what is the role of our white blood cells in defending our body from disease? Essentially, how does our immune system work? And the second is, well, why don't we get sick a second time once we've been infected the first time? And finally, you're often told it's okay to play in the mud, but it's full of pathogens, so why is this okay? Well, basics first of all. Pathogens come in four different types. We have bacteria, viruses, fungi and protists. Now we've all heard of these different pathogens. There are common diseases for each. Bacteria causes diseases such as salmonella and often cause sickness and diarrhea. Viruses, I'm sure we've all heard of a virus or two. Fungi, they do cause us some diseases like athlete's foot. And finally, protists, the one that everyone forgets, but the most common example of that you come across or will have heard of is malaria. And protists and viruses, fungi, bacteria, they're everywhere in our environment and all around us. But we don't get sick from them all the time. And that's because of the role of our immune system. Now, I'm sure your parents have said to you either absolutely don't play in the mud or go and play in the mud and get dirty and it's really good for you. And other days you're told you have to wash your hands for 20 seconds. So why is this? Why do we get this mixed message? Well, it comes down to about how the way our immune system works. Our immune system is made up of white blood cells, and they are the element that helps protect us against disease. And there's different types of these, and they have different functions, and that's what we're going to explain. But we need to be clear on what a pathogen is and how that works too. In terms of our immune system, there's different layers of our immune system. They're referred to as different levels of defence. The first line of defence is things like your skin. That is a natural barrier to pathogens getting inside our body. Things like our stomach acid, and they stop many of the bacteria that we perhaps eat and causes further infection. I think how many times you've seen a dog perhaps eat something that you really wouldn't want to touch and the dog seems quite unharmed by it. It's down to the stomach acid killing those bacteria before they can get into its body. The second line of defence is a type of blood cell, a white blood cell inside our body, known as a phagocyte. And these are okay at finding and killing pathogens that get in, but their role actually is more involved in letting the next level of defence know, the third line of defence. And these are our B cells and our T cells. And they've got two kind of clear jobs. T cells, they kill your infected cells. Their job is to stop infection spreading further. I always can't remember that T, there's a T in the word infected and T in T cells, and those two go together. Meanwhile, the second type of cell works in parallel. They're like the chemical warfare in an army. And they release antibodies, and they tend to operate at a distance, and they release a chemical into our blood, and that chemical, known as an antibody, travels through the blood and stops pathogens from working. They can either kill it directly, or they can glue it up, or they cause loads of them to stick together, and then those phagocytes can go around and engulf them and eat them and digest them and stop the disease spreading anymore. Again, I tend to remember the fact that B stands for antibody, or the body part of antibodies. But how does our immune system recognise individual pathogens? And you might have heard much about this in the news. Well, one way is to imagine a jigsaw puzzle. In the jigsaw puzzle shown, there's hundreds of different pieces. A pathogen is like just one of those pieces of jigsaw. But in amongst all the other bits, there's just one piece that will perfectly match. And that one bit that perfectly matches is one of our white blood cells. And we have thousands of different white blood cells in our body, all subtly different in different ways. And when we first get infected, that pathogen will travel around our body through our blood, and it will pass by many of those different white blood cells. But only one of them will match. And that can take a couple of days before that match happens. Once that happens, those two pieces join together. And when they join together, that's the point at which our immune system, our white blood cells, can kill the pathogen. The trouble is, and this is where vaccines and infections different, if we have a really high dose of a virus or a bacteria get into our body, then it tends to cause a lot of damage to our body before our immune system has time to kill it off. If it's just a low dose, our immune system has time to build up in numbers. That individual single white blood cell can multiply many times until there's enough of it to produce enough antibodies or kill the infected cells and remove the pathogen from our body. So in terms of our immune system and how it works, it's actually really quite complex, and we always keep it simple at GCSE. And so, to keep it simple, the antigens that are on the surface of the pathogen, we see it there on the virus, well, they come in many shapes and different sizes. So every virus is unique. Every different type of virus, whether it's a common cold, and whether it's the flu, or whether it's other diseases like Ebola, they all have different antigens. So only one white blood cell will recognise them, and they won't recognise another one. But there's a number of our cells that will kind of work to bind to that virus. And that could be the phagocyte, first of all, or it could be some of our B and T cells will recognise those antigens. And all of them will work together to fight off the virus. Once they join on, T cells, well, they'll kill the infected cell. They literally go and kill our own cells, but the point of that is they stop the virus being able to spread further. Meanwhile, B cells will join the antigens, and when that happens, they release those antibodies. The phagocytes, well, their job is again to enhance that response. So either the fact the antigen binds directly to the B and T cell, or it can bind to the phagocyte. They're all working simultaneously. But the phagocyte then again helps all the other cells work a little bit faster, releases chemicals in the blood that help them to work more effectively and actually move around faster as well. And finally, once they're activated, B and T cells, well, they'll turn into memory cells. So once their job is done, they don't die off. They change into a different type of cell that becomes semi-dormant in our body, but in much larger numbers than it was the first time. So the next time we're infected, there's more of those cells already. They're more likely to meet the antigen, and therefore they can respond more quickly. Well, back to my original question then, why is it okay to play in the blood? Play in the blood, play in the mud. Well, it's back to those three things that we pointed out. We have a primary defence, so those pathogens inside the mud won't get inside our bloodstream. But should that fail, should we have a little cut, well, then we have our white blood cells to potentially remove that pathogen. And as a child, most of the pathogens that you'll come across in mud, you've either been vaccinated against or aren't going to cause you any great harm. And it's actually been shown from research that it's good to have low exposure to some of these pathogens that are in the soil, in the mud. And then what that means is our immune system has something to work on, and it stops the immune system starting to develop allergies. Right, thank you for watching.